Hello, Internet friends. Thank you for spending your time with me today. And let me start off by saying this is just a brief interactionless time we've got together now. Please treat it as an invitation to speak more in the future. I'm Jim O'Leary. I run engineering at Signal, and you can ping me to continue this conversation using jimio@signal.org. And so I was invited in today for a talk from the trenches about real-world privacy deployments. There's often a lot of great academic or research material in a conference like this. However, some things that work really well in the laboratory will fall over once you introduce society to the model or deploy your software to the masses. Poor network connectivity, lost mobile devices, and complex societal contexts can make the greatest ideas fail when deployed to the world. So you might think I'm here to tell you about some cautionary tales of production deployments gone awry, but actually I'm here to tell you about some things that work very well at a global scale today, along with the principles you could take and apply to what you're working on to achieve the same global impact. The first of these is the belief that privacy is fundamental, simple as that. And you can go very far in your system designs and organizational decisions by stating this and advertising it at the very beginning of any design decision you make. Second is that you're building software and you're deploying systems for people, and not just people, you're building for everyone. And so you need to account for differences in technical sophistication, but also culture and beliefs as well. Something that makes Signal unique is our end-to-end encryption, where we can't analyze or recover your data. And I think that that commitment to minimizing any sort of data that's stored anywhere on any systems is something that you should also take and move forward with. A quick hit from the engineering side of things as you're implementing and deploying some privacy technology. A nice thing to do for correctness and consistency and even just simple development speed is to write code once into libraries that are then shared across multiple systems. And lastly, while we're very protective of your data, we're very open with our technology. And we feel the best way to keep your communication private is to be transparent about how we build our products. So at the heart of all this is communication. And let's begin with two people. But this could also be a collection of many people, or it could even be one person talking to themselves, as I am doing right now in the smoky, dark California night here. But fundamentally, people want to communicate. And we want to enable conversation with some of the same properties you get if you're having a conversation face-to-face. When you meet your friend at the park, every word that you communicate isn't delivered through some intermediary party. Your eye movements aren't tracked throughout your discussion to increase engagement for future conversations. And nobody's eavesdropping to determine the best advertisements to run in order to influence your next luxury item purchase. We want to provide a channel of pure human connection. And so let's illustrate what that looks like here. You begin with a simple message, and since we're talking about global communication in this case, there needs to be some sort of system or infrastructure that will get the message you want to send to the person that you want to have receive it. So in this case, Bob sends his message to a chat provider or a service. Alice then connects and authenticates and retrieves and sees the message that Bob had sent for her. In the era before the 2010s, your message would typically hop through the internet using plain text transmission protocols to be snooped on or modified any step of the way. You could think of this as a sort of global game of telephone where one system passed along your message from its peer to the next peer until it reached the recipient that you intended for it to be delivered to. As an industry, we determined that this was bad. And as a result, transport layer security, SSL, HTTPS, these all became mainstream technology, and the whole planet became a little bit more private and secure as a result. But even though the connections of the server were more secure, the message still traveled through the server in plain text. So you've got transport layer security, but you've got this payload that is delivered by a secure channel and decrypted and available on the server. Granted, it's a server or service that you should trust, but do you need to actually, and are there ways that we could build this better? It's also been a long time since any communications platform was powered by a single server. And so when you're sending this message and it's going through a third-party service, there are actually going to be a collection of front-end and back-end services touching, processing, maybe logging, perhaps analyzing, maybe storing the contents of your original conversation. And often if network connections were protected as they came in from the internet, they're often unprotected within the data center. And this model of a crunchy on the outside, chewy in the middle infrastructure was prevalent across many popular service providers. And some external people noticed. And so this little snippet here is a friendly note from a presentation that went public in 2013 or so about how it might be possible to snoop on data as it was being transmitted within data centers, and SSL had been terminated at the external point. But even with TLS deployed inside data centers now more prevalently, still the actual meat of the data itself will land on all these systems. And so what we want to provide is a means for people to communicate that is protected no matter the transport or the systems involved, in a way that they can trust the applications responsible for the reliable delivery. So we are Signal. We're a nonprofit organization building open source privacy tools to protect free expression and enable secure global communication. We have an active collection of public code repositories. We share our source code on GitHub and keep it up to date alongside our releases. In addition to the client code that you might run on your phone or your laptop computer, we also open source our server-side code, as well as libraries and utilities too. We want to influence the technical industry at large, but also operate transparently so that you can kind of play along and participate in what we're building for everybody here. And in addition to our code, we also invest in quality writing and sharing of our specifications. And so if you haven't yet used Signal today, I encourage you to go do so. But you've used some of our technology almost certainly in communicating with somebody using a modern day messaging application. So every single WhatsApp message, along with the secure conversation modes of apps like Messenger, Skype, Google Duo, use Signal protocol for encrypted end-to-end messaging. As a nonprofit organization, we don't have competition in the traditional sense. We compete with insecure technology like SMS, MMS, and other plain text protocols. And we feel as if we win when the world is more private and secure. If that means the biggest players in tech adopting and deploying the same technology that we use to run Signal, that's a win in our eyes. And we feel noble and righteous in providing that to the community. We're funded through grants and donations from people that use the service and support our mission. So once more, we want to provide a means for people to communicate that is protected no matter the systems involved, in a way that they can trust for responsible and reliable delivery. Now, I could get into some of the details of the double ratchet protocol that powers encrypted messaging for us, but I'm almost halfway through my 15 minutes here. And also, that particular development dates back to 2010 and has been running reliably in production at global scale for years. So I joined the organization last year, and I'd rather spend this brief time we've got together talking about some of the things I've been more actively involved in developing recently. And so people send lots of messages every day, billions of messages every day, but calling is really, really big too, and growing on our platform, particularly amidst a time of a global pandemic. And so, we are not just exchanging text to communicate today. I think that there's some really valuable full fidelity communication that needs to happen over an audio and video channel. And so we have calling in all of our applications now. One of the ways we did this is to harken back on this principle of writing code once. And so we've got an open source project called RingRTC that forks the WebRTC project, modifies it slightly to keep everything up to date from a security perspective, make some explicit privacy decisions, and then we wrap all that in Rust for memory safety and type safety, and then deploy it across all of our clients and use it for building out the calling features we've got today and the calling features we will have in the imminent future too. I mentioned building for people as one of the principles up front, and want to highlight some additional functionality that we deployed recently in the kind of spirit of making sure the technology you're building can be adopted by people that might not be super sophisticated from a technical perspective. And so on Signal, your contacts live in your contact book local to your device. But we're working on enabling people to reach out and talk to people without having to exchange a phone number with one another. In a world in which we do this, it's important for you to trust who you're speaking with on the other side. And we've got some crypto-backed features like safety numbers that will change when it seems as if somebody is re-registering with a number that you've got stored in your contact book already. But we want to make it such that if somebody is not in your contact list already and they're reaching out to you for the first time, it's evident that this is perhaps like a new person or a new contact, and somebody should make a trust decision to continue to have a discussion with you on the Signal platform. So I run engineering here. I've got probably these like 3 words I'll use to describe the way that we envision our development here. They're secure, reliable, and fast. And to speak towards a thing we did, started about a year back and are close to deploying to production at the moment now, is our Signal private group system. And so from the earliest days of groups at Signal, we never know who's in a group, who's sending what the group is about, what the avatar is, anything like that. The initial implementation used distributed client-side state to basically make a group conversation look like a collection of one-on-one conversations, such that the server doesn't know about group size, it doesn't know about any of these other things I mentioned before. But one of the challenges with distributed client-side state is that it's not as fast or reliable as we'd like it to be. So we did a collaborative effort with folks from Microsoft Research, as well as our own internal folks and collaborators beyond just this set here on the paper, so that we can kind of go back to this, I guess, practice of open source, open protocols. And so we've got a 40-page white paper up on ePrint that describes the crypto involved here. And we also open source the implementation. Again, this is also written in Rust. It wraps the specific crypto details in a layer that's implemented once for correctness and consistency across our client and server applications. But encrypted messaging is great. We want more people to use it. And nobody outside of the technically elite really cares about key size or Diffie-Hellman exchanges. People want to use messaging in a way that they enjoy too. So over the past several months here, we've worked on features like reactions, view once media, and stickers to make Signal a little bit more fun for people that are talking with their friends and family. And we didn't just introduce stickers though, we introduced them in a Signal type fashion, where even the Signal packs that float around our ecosystem that we run are end-to-end encrypted. We don't know anything about the contents of these sticker packs. We don't know about the creators of the sticker packs. They are stored on your device locally and forwarded around as part of your conversation with your friends. And so this makes Signal like unique in a lot of ways, that even things as seemingly trivial as stickers are in line with our store no data philosophy, in which we don't know what's being shared or distributed across the ecosystem, because we feel this is your data and not our data. And Signal has always held a place in the world. Like, our small organization powers a lot of private and secure communications right now. But more than ever, it seems, people need us. And we are listening and ready to support folks as they need our help. In the US and across the world, there are movements for equality and justice, and we want people to be heard and we want people to be safe. And this phenomenon that was occurring over here in the States is that photos are being taken and shared on social media at some of these gatherings or protests, and people are then being identified by law enforcement or rogue internet investigators and identified and threatened or arrested or worse. And so we were talking to some folks that use the app, and they kind of inspired us to ship a local, on-device only, using system APIs, facial recognition, and auto blurring feature in the app. And so your data doesn't go off to be analyzed and come back to the server with facial blurring. This all happens on your phone. And it's a way that we just want to provide a convenient feature for people to protect themselves and the folks around them. And the reason we do all this, right, is that privacy is fundamental. We talked about encryption and security, but why? It's all about protecting the data. And when governments come knocking and looking for data, it's a nice sort of liberating place to come from, where you don't have any data to share. It saves you from maybe difficult policy decisions or regrettable partnership decisions that an organization or a company might have. So, to wrap things up here and aim for hopefully squeezing this all within the 15 minutes I've been allocated, approach the systems that you're designing and running by fundamentally believing that privacy needs to be at the core of everything you build. Think about people and think about everyone. Store as little as data as possible. Encrypt everything you can, and then operate in the open. And I will invite you to join us in doing so as well too. So once more, I'm Jimmy O at signal.org. I thank you for your brief time today and look forward to conversing more in the future. Cheers, everybody.